This video is going to talk about multiplying and dividing rational expressions. So our rational expressions will get more complicated. They'll involve polynomials, but just to refresh our memories on multiplying fractions in general, because rational expressions are just giant fractions. So when you multiply, you can multiply across the top, the numerator times the numerator. So 3 times 4 is 12, and 7 times 9 is 63. And then you'd have to try to reduce. So you'd have to see what goes into 12 and 63. Or you could, from the beginning, recognize that 9 is the same thing as 3 times 3. So if the 3's reduced to just be 1. And so in the numerator, 1 times 4 is 4. And in the denominator, 7 times 3 is 21. So 12 over 63 would reduce to be 4 over 21. And then dividing fractions is the same thing as multiplying by the reciprocal. So 8/5 divided by 6/7 is the same thing as times 7 over 6. And so I would want to reduce the fact that 8 is 4 times 2 and 6 is 3 times 2. The 2's cancel, and so in the numerator, 4 times 7 is 28, and in the denominator, 5 times 3 is 15. So 28 over 15 is the answer. So we're going to go through a few example problems here of those concepts. So number 1 says 3x, I'm going to rewrite that because I can, 3x squared minus 3x over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. And so before I start reducing, I'm actually going to see if there's any factoring that can be done. So I'm going to split this up into 4 separate problems and try to factor each of them. And so first of all, I'm going to factor 3x squared minus 3x. And so I look for what they have in common. Their GCF is 3x. And when I factor out the 3x, I'm left with x minus 1. In the denominator, the blue, I'm going to take standard factoring, which means 2 sets of parentheses. X squared factors into x and x. And then what multiplies to be negative 5 and adds up to be 4 is a positive 5 and a negative 1. So I can already see some reducing that's hopefully taking shape here. In the next numerator, I'm going to factor. So I've got 2 separate kind of quantities here. X squared is x and x. 2 numbers that multiply to be negative 20 and add up to be 1. So multiply to be negative 20, add up to be positive 1 are positive 5 and negative 4. And then in the denominator, 3x is just 3 times x, so that doesn't factor at all. And so now I'm looking for factors that can reduce. So the 3 and the x can reduce, the x minus 1s can reduce, and the x plus 5s can reduce. And so all that's left in the numerator is x minus 4, and nothing's in the denominator. So whether I put parentheses around it or not, the answer is x minus 4. For the final answer. So I have to factor first to see what I can reduce. Number 2 says 2x squared minus 10x over x squared minus 25 times just x plus 3 over 2x to the third. So I'm going to split this into 4 separate potential factoring problems. So in the first numerator, all I can do is factor out a common denominator or common GCF, which is 2x, and I'm left with x minus 5. In the denominator here, that's the difference of 2 perfect squares. So x squared minus 25 factors into x plus 5 and x minus 5. And then x plus 3 doesn't factor at all, but I'm going to put it in parentheses because if any of it's going to reduce, the entire thing has to reduce. And then in the denominator, I've got 2x to the third. And so let's talk about things that reduce. I know that x minus 5s reduce out. I know that the 2's reduce. And so now I have to think about the x's. So x to the third means x times x times x. So one of them is allowed to cancel, and then I would be left with x times x, or x squared, in the denominator. And then let's see here. That's all that reduces. So in the numerator, I've got x plus 3. And in the denominator, I've got x plus 5 and an x squared. It's standard to see that written in the front. So x plus 3 over x squared times the quantity x plus 5. And this is the final answer. There is no need to multiply that x squared, distribute it. In fact, I would not want you to. I'd want you to leave it out front. Okay, and then we'll try this practice problem. So we've got 5j plus 4 over 5j squared plus 6j minus 8 times j plus 2. So here's a couple things I want to notice. The first thing I want to notice is that anytime it's a whole number or just a polynomial with what looks like no denominator, I can put it over 1. And then second of all, I want to factor this 5j squared plus 6j minus 8. So I'll run through the AC method. Again, the AC method means I'm going to label A, B, and C like I would for the quadratic formula. And I'm going to take A times C, 5 times negative 8, which is negative 40. And I'm going to look for two numbers that multiply to be negative 40 and add up to be 6. So multiply to be negative 40, it could be 1 and 40, it could be 2 and 20, 3 doesn't go into it, it could be 4 and 10, and it could be 5 and 8. And so the two numbers that multiply to be negative 40 and add up to be 6 are negative 4 and positive 10. So that's how I'm going to split up this middle term. So this is going to say 5j squared minus 4j plus 10j minus 8. And then I'm going to factor by grouping. So I'm going to group together the first two, group together the second two, and take out the GCF. So I'll take out a j, and then a 5j minus 4 is what I'm left over with. Factor out what 10j minus 8 have in common, which is plus 2. And then what's left over when I divide out the 2 is 5j minus 4, which means that denominator turns into 5j minus 4 times j plus 2. And so all that was doing was factoring this denominator. The numerator can't factor, so it says 5j plus 4, and then times j plus 2 over 1. And that is a quantity. So those can cancel, the j plus 2's. 5j plus 4 and 5j minus 4 don't reduce. So 5j plus 4 over 5j minus 4 is the final answer. Oops. And whether I put it, the times 1, whether I put it in parentheses, it doesn't matter. But those don't reduce. They don't even reduce to be negative 1 because the j's are positive in both situations. That is the final answer. If I had something like j plus 1 and then j minus 1, those are done. But if I had j plus 1 and negative j minus 1, then technically I could factor a negative out of the bottom, and then they would reduce to be a negative 1. But in this case, though, that doesn't happen because the j's are positive in both cases. So I'm actually going to stop this video, and this will just be multiplying, and then in the next video we'll do dividing.